Hi, my name's Tim Martin. I teach Earth Science here at Greensboro Day School, a K-12 independent school here in Greensboro, North Carolina. For the last number of years, I've been actively seeking ways to engage my students with both the use and analysis of real scientific data and engaging them with hands-on, inquiry-based activities to address concepts that are relevant to understanding Earth system science topics. Understanding climate science, particularly paleoclimatology, is vitally important if we as a species are going to understand how we're impacting our environment. Many educators have addressed these topics by developing class lessons that model work done by paleoclimatologists from around the world. I've reviewed various activities that involve counting little slips of paper or counting colored glitter and colored candy like M&Ms or Skittles to represent various microfossils that may be found in ice or other sedimentary records. I and the team of scientists with whom I've been working feel a far superior way to teach students about climatology is for students to actually do climatology.
In 2009, I was selected as a Polar Trek teacher and joined an international scientific research expedition to Lake Elgagitkin in the Siberian Arctic. Lake Elgagitkin is a fascinating location. Formed by an asteroid impact 3.6 million years ago, it is one of the few large craters on Earth that is situated in igneous rock, thus making it of particular interest to planetary scientists. Most importantly, unlike other lakes in the high Arctic that have had their sediments disturbed by continental ice sheets, Lake Elgagitkin, located in central Beringia, was never glaciated. Thus, this lake holds the longest undisturbed climate record of any location in the continental Arctic. The goal of our expedition was to extract lake sediments and impact rocks to understand the crater formation as well as the excellent high-resolution climate record preserved in the sediment. On expedition, I worked with the science team as well as worked to communicate the science through blog, video.
Following our expedition, I maintained close relationships with the research team, and together we've developed lessons where students model the work from this expedition. Our work has been shared at local, national, international conferences, as well as summer teacher workshops at the University of Massachusetts. Our first lesson involves studying real data sets from Lake Elgagitkin. Students learn about climate proxies by studying diatoms and pollens found in a particularly interesting 2-meter segment of our 400-meter core. Pollen data and micrographs of diatoms are paired with high-resolution, life-sized images of our core. In this lesson, students make measurements, analyze, and graph their results to learn about past climates. Since simulation and modeling exercises miss the fun and challenges presented by fieldwork, I take my students to this pond here on our school campus. We extract sediment cores and look for proxy weather and climate data in our local environment. I figured that if climate record was being preserved in an Arctic lake, pollen, diatoms, and other proxies are also building up here in the stormwater detention pond on our school campus.
After extracting the sediment cores, students measure, analyze, and study local mud using normed procedures. We evaluate Munsell sediment color, measure texture, and document various properties of the cores. After making sediment smear slides, students are frequently excited when they discover diatoms in their core samples. Whether by discovering annual autumn leaf layers or microfossils, students become scientists and quickly develop a deeper understanding about how geologic processes are preserving a record of our current environment and climate.
As with any real science, the results will vary and may be unpredictable. Certainly they'll depend a lot on your geographic area. I hope you find this useful and you give these lessons a try with your students.